Welcome to Study Loop.
This is problem 98 of chapter 7.4 of Vector Mechanics for Engineers, Statics and Dynamics. So for this problem, there is a cable that stretches from A to E. There's a load applied at B, which is 5 kilonewtons, at C, which is 5 kilonewtons, and at D, which is 10 kilonewtons. The horizontal distance from A to B is 2 meters, B to C is 2 meters, C to D is 3 meters, and D to E is 3 meters. The vertical distance from A to E is 4 meters. For A, we are tasked with finding the vertical distance from A to C, which is the distance C. And for B, we are finding the reaction at A and the reaction at E. And also for this problem, they want us to treat the section D and E as if it is horizontal. So I redrew for the first part to start off this problem. You make a free body diagram for A to E, and you make the distance D to E horizontal. And when you do this, the only reaction force at E is in the horizontal direction. And adding in the reaction forces of AX, I put in the negative X direction, and AY, I put in the positive Y direction. So to start off this problem, we are going to do the sum of forces in Y. So that equal to 0. We're going to subtract all the loads and plus AY because it is in the positive Y direction, set that equal to 0. So AY is 20 kilonewtons. Now we're going to take sum of moments around A and set that equal to 0. And this will equal E, which is in the horizontal direction, times 4, because the vertical distance between A and E is 4 meters, minus 5 times 2. And this is the force at B. It creates a negative moment around A because it is in the clockwise direction. And it is times 2 because there is 2 meters between A and B in the horizontal direction. Minus 5 times 4. This is for the load at C. It creates another negative moment in the clockwise direction around A. It is times 4 because there's 4 meters in the horizontal direction between A and C. And minus 10 times 7 meters. This is the force at D. It is another negative moment in the clockwise direction around A, and times 7 because it is 7 meters in the horizontal direction between A and D. And again, that's set equal to 0. So we're going to go ahead and solve for E. And after simplifying everything, E will equal 25 kilonewtons in the horizontal direction right here. So now we can do the sum of moments, or the sum of forces in the X direction, set that equal to 0. So we know AX is in the negative direction, plus E, which is in the positive direction. So negative AX plus 25 equal to 0. So AX is negative 25 kilonewtons. Okay. So we can go ahead and take the moment around C. We're going to split this off right here and just do a free body diagram from A to C. We're going to do a sum of moments at C, so that equal to 0. This will equal AX times the distance C minus AY times 4, because there's 4 meters in the horizontal direction between A and C, plus 5 times 2, which is the force at B. The force at B creates a positive moment around C because it's in the counterclockwise direction. And it's times 2 because there's 2 meters in the horizontal direction between B and C. So we're going to go ahead and plug in some values. So this will be 25 dc minus 80, because AY was 20, so 20 times 4 is 80. And we're going to go ahead and move 5 times 2 over to the other side, so it's negative 10. And simplifying everything and solving for DC, DC equals 2.5 5.8 meters. And this is the answer for part A. Now for part B, we already know what AY and AX equal, so we can go ahead and solve for the total reaction of A. So A is the square root of AX plus AY squared, both squared. Plug in the values that we obtained earlier, we will get 32 kilonewtons. We also need theta A, so we know what direction the total reaction is in. So the inverse tangent, AY over AX, make sure your calculator is in degrees, and this will equal 38.66 degrees, and this will be in the second quadrant. And I'll explain why. So our graph of A was like this, and AY was in the positive direction, and AX was in the negative direction. So our reaction force will be in the second quadrant. So now the last thing they wanted us to solve for is the reaction at E. And because there's only one reaction at E and it was in the X direction, E was 25 kilonewtons, and that is it because there was only one reaction force. And it is in the positive X direction, so theta would equal 0, and it is in the positive X direction, so it'd be right here on the graph, positive X direction. So these are the answers for part B. For problem 98.